Over the last century, the Cameron Creole watershed has experienced saltwater intrusion, increased tidal effects, and reduced freshwater in the system due to a variety of factors, like changes to shipping channels, the introduction of the Gulf Intercoastal Waterway, and major hurricanes like Rita and Laura. These negative influences have drastically changed the hydrology of this region and degraded the system as a whole. Hydrology is the study of the movement, distribution, and management of water. The main restoration goals for the Cameron Creole watershed are to move more fresh water through the system, reduce salinity back to its original state, increase aquatic vegetation, and improve wildlife habitat.
The Cameron watershed, which it's part of, is a large system in Cameron Parish along Lake Calcasieu. It receives water from Calcasieu Lake. And when they built the Calcasieu ship channel and connected to the Gulf of Mexico, a lot of salt water came in and damaged the water. There had been several projects leading up to this project to seal off the Cameron Creole watershed from the salt water, and this last project was a component to bring fresh water in to help flush the Cameron Creole watershed out.
This project aims to restore approximately 22,510 acres of marsh and open water and is achieved through 3 structures. The first structure, a freshwater diversion, allows for more freshwater input from the Gulf Intracoastal Waterway into the watershed. The diversion is composed of 8 culverts or channels with a gate that slides up and down to control the water flow. Controlling the water flow is critical to maintain the right salinity and water levels of both the lake and the watershed. Reintroduction of freshwater not only provides essential sediment and nutrients to the region, it also helps push out salt water that intrudes with high tide or storms. To protect the structure from erosion, rock protection was added to the shoreline. These rocks help break up wave action to stabilize the shore and lower erosion rates. Finally, the 2 terrace fields were built in what was a 1,000-acre open water area. These terraces slow down the water movement coming from the diversion. By slowing the water, vital nutrients and sediment can settle out of the water column, and the fresh water will stay in the system a little longer. Over time, these nutrients and sediment support the development of emergent marshes. These marshes are important as they sustain the base of the food chain. The nutrients allow for bacteria and microbes to establish, which allows for plankton to take hold. Plankton is the base of the food chain, supporting organisms like some finfish, shrimp, and copepods. This paves the way for larger fish, marine mammals, and birds to have a food supply, establishing a sustainable ecosystem. How do the freshwater diversion structures help restore the marsh and protect the area from saltwater?